So in this video, I want to introduce you to solving equations when you've got an x on both sides of the equal sign. Now, in the previous few videos, I've been using a method that ended up with us doing this. So it was essentially sowing the seeds for this, but don't worry if you haven't looked at those, or if you're looking at these in order, okay? You've had a bit of an inkling as to how it works, and in this video, hopefully I should clear up some of the issues. So here are two examples, and these are probably some of the more kind of basic versions that we can really write down, okay? Now, one thing that I have heard people use as a way of explaining what the method is to always subtract away the smallest value of x. So you've got a choice here. You've got 8x, you've got 5x. So if you subtract the 5x, for example, here you've got 2x and 7x, so you subtract the 2x, okay? What I want to highlight is that this isn't always the best idea, okay? And it can lead to unnecessary working. The reason that people teach subtract away the smallest value of x is to avoid negative numbers as much as possible, which I can understand, okay? If you're not a fan of working with negatives, then subtracting away the smallest value of x is a good idea, but it can lead to more stages of working. So there is a bit of a trade-off there. So, for example, with this one, if you subtract away the smallest value of x, you're subtracting 5x from both sides, you're going to get 3x is equal to minus 9, and then you can divide both sides by 3, and you get x is equal to minus 3. Okay, great, works perfect. If you subtract the smallest value of x from this one, that's the 2x. So if you subtract 2x from both sides, you're going to get 0 on the left-hand side is equal to 5x plus 15. Then, because I've got the 5x plus 15, let's subtract the 15 from both sides. And then, because I've got 5 times x, let's divide both sides by 5. And so x is equal to minus 3. Okay? That is a coincidence, by the way, the fact that these two have the same answer. So that wasn't planned. Okay, so this all seems reasonable. It works. It's fine. Okay? But why not just do this? And instead, as a first step, subtract the 7x from both sides. So you get 2x take away 7x is minus 5x is equal to 15, and then divide both sides by minus 5. So x is equal to minus 3. Okay? That is just a little bit quicker. Okay? Why not do that? So what I'm trying to do when I'm solving an equation like this is I'm trying to isolate the x. My target is, when solving an equation, to get x equals, okay? So the more I can make the equation look like x equals, the better. That's essentially what my process here is, okay? So if I've got this equation, in order to make it look like x equals, I need to have all the x's on one side of the equation. Okay, I need to have all the x's, something x is equal to some number. So because I've got this number here already, just leave it where it is, and let's get all the x's onto one side of the equation. And I can do that by subtracting 7x from both sides and getting the minus 5x on the left-hand side and the 15 on the right. So I am one step closer to just getting x equals. That is my plan, okay? If instead I subtract the 2x from both sides, I am not much closer to getting x equals. I've put everything onto one side of the equation, okay, to get it equal to 0, which in some cases can be a good idea with certain equations. But with this one, it doesn't feel like it's really got me any closer to the answer, okay? So Another example would be something like 10x is equal to 13x plus, let's go with 18. Okay, so 10x equals 13x plus 18. So what I would be trying to do is going, right, I want to get the x's by themselves. Okay, I want to get x equals. So it makes sense for me to subtract the 13x from both sides to get minus 3x is equal to 18, and then divide through by the minus 3 to get x is equal to minus 6. Okay? And it doesn't matter if the term is on that side or it's looking like this. Okay? This is precisely the same equation. It's just I've rewritten it, so I've got the 10x on the right-hand side and the 13x plus 18 on the left-hand side. My target here is still to get x equals, and the fastest way to do that is to subtract the 13x from both sides to make it look as close to x equals as possible, and then to divide through by the minus 3. Okay? So that is my target, to get the x equals, and if you target that and you're happy with working with negative values, negative numbers, then this is really the way to go.